So now we've seen that there is this phenomenon that we've called polarization that has something to do with the relative orientation of these disks, but life doesn't have such disks floating around with it. There wouldn't be much interest if this didn't actually show up through other phenomena in the everyday world. So what we're now going to do is do a demonstration that shows polarization showing up from a simple phenomenon you're all very familiar with, and that is reflection. We've got a laser set up here that bounces off a piece of glass here, and I can see the reflection from the glass on this screen here, and I can note the angle at which the mirror, or the piece of glass, it's not a mirror, it's a standard piece of glass, is oriented with respect to the laser over here. So now we're going to dim the lights and look at the reflection a little bit more carefully as I move. So you can see those two dots, that's reflection off the front and back surface of the glass. And you'll see that it looks pretty normal. But now I'm going to put that big piece of polarizer that we had over on the light table in front. And notice that now, as I rotate, it gets much dimmer at one spot than any other. So right around there, it seems to be particularly dim. It's hard to know exactly where the minimum is, but notice if I take the polarizer away, it gets quite a bit brighter. So the light that's been reflected from the glass is in fact polarized slightly. Let's turn the lights back on and notice that the angle at which that's happening is on our protractor here 34 degrees. So if we're still recording, we're going to take note of that number and use it for something in your calculations as you finish up the lab.